see is rude, crude, and made in one night, and not for the viewing of children. So please, close their eyes. But before we start, let's have a brief moment to rock on. And always remember, this was meant for your amusement.
Crikey, my name's Crocodile Dundee, and I'll be showing you around our great forest and vast waterfalls today. Now, as you can see, there's plenty of vegetation and a lot of water, so there's gotta be some raging beasts. But my friend John here, he's from around here. He doesn't talk or say much, but if you pay attention, he'll point us out some great beasts. And today, we'll be hunting down some circles. Circles, ellipses, parabolas, and hyperbolas. And we'll be getting them and shooting them and stabbing them, cutting them up, and showing them who's boss, just like the great alligators. Now, I got the equation for a circle. It's x minus h squared plus y minus k squared equals 1. Yeah, just 1. And you should write that down because it's important. It's going to help us find some circles. Now, we're going to go out to this vast wilderness and find us some circles. Oh, I found me a circle. Yeah, circle. Alright. So what we gotta do is we gotta sneak up on it. Because if you don't watch out, they enclose you. Because their points are adjusted to their H and K. And you have to be very careful. Because they seem like they're simple. But really, they're really, really hard to catch. And if you make one slip up, you're dead. So, I'm gonna adjust the camera so you can see the circle. What? What? You don't know what an ellipse is? Oh, ellipses. I remember ellipses back in Vietnam. Oh, I can tell you about ellipses all day. All day, every day of the week, baby. Every day of the week. So ellipses. You want to know a little bit about ellipses? Ellipses, their equation is x minus h squared over a squared plus y minus k squared over b squared. That's all about ellipses. So now you know ellipses and what they are. What? You've never seen an ellipse? Oh, seen ellipses? Oh, fine. Let's go ellipse hunting, baby. Ellipses. Here's an example of an ellipse. The top's an ellipse and the front's an ellipse. The front's got a bunch of ellipses. And an ellipse, just like a circle, except it's on top of a squared and b squared. And what those numbers are is up in the problem. I say it's 49 and 36, right? Square root of those is 7 and 6. So that means your intercepts are 7 and 6, both positive and negative on the x and y axis. However, the way you determine which number goes on which is where the bigger number is under. So let's say the bigger number, 49, is under x. It'll be elongated on the x-axis. The bigger number is under y, it'll be elongated on the y-axis, not the x-axis. Now, ellipse is just like a circle. just like a circle, is round. So it looks like an oval, pretty much. But another thing you gotta know is that an ellipse is just an elongated circle. So the equations are almost exactly the same, except you put x over a and y over b. Now always remember, a and b are squared and the problem is equal to 1. And if you lose track, lose what you're doing, and you can't figure out what an ellipse is, just remember, I know where you sit. Now, tell your mom hello, and I'll be on my way talking about ellipses. Now I'm here to talk to you about parabolas. Parabolas, kind of like half a circle, but not half a circle. It's just like a big arch. And a parabola is the only one that has a directrix. And a directrix is a line. That's either an x-axis or y-axis. And it's just a solid line. Now, they also have a foci that's equally distant from the directrix as is the origin of the parabola. And the origin of the parabola does not have to be the origin of the graph. It can be anywhere. That's where h and k comes in. And the equation for a parabola is y minus k squared equals 4a times x minus h squared. H and k is your center, and x and y, obviously x and y, not that hard. Now, where your foci is and your directrix is based upon what 4a is. Now let's say the number is 16 in the equation. 4 times a equals 16. You divide by 4 and you get a equals 4. So from the origin of your parabola, 4 places down and 4 places up is your directrix and your foci. Easy enough, right? Now 2 real life examples of parabolas are bows. You shoot a bow and it goes up and down, an arc, like a parabola. Another real life example of parabola is a throwing axe. When you throw it, it goes up, and over a distance it comes down. Easy enough, right? Yeah. Hyperbolas. I'll show you a little bit of hyperbolas. Hyperbolas. Now, hyperbolas are the ones where it's like 2 parabolas, but they're opposing each other. They're against each other, going in opposite directions. Now, hyperbolas. 2 real-life examples of hyperbolas are hourglasses and nuclear reactors. First, let me cover nuclear reactors, as in radiation, as in produces electricity. So, nuclear reactors, they make electricity from a nuclear reaction. Whoa, who would have thunk it? But the reason they're hyperbolas is because the outside shell, that weird looking kind of ice cream cone thing, is made to have a bend in it. So that all the way around is a hyperbola. Now, it's made like this because it uses less material, conserves energy, and it's better architecture and resists wind and earthquakes as well. Now, hourglasses. Hourglasses have an inward hyperbola shape, which means in their hyperbola comes in and makes a little cone, goes back down and enlarges at the bottom. The reason it has this shape so that time will pass only a few grains at a time. That keeps time better that way. Because if everything went together at once in hourglass, you'd lose track of time. Hyperbolas. Now, let's go on that treasure hunt. Yeah, so I'm outside on my treasure hunt. And now I'm looking for a tall thing, like that light post over there, to use my trigonometry on. So yeah, I'm out here at this light pole right here, right? And let's say for experimental purposes that it's 5 feet tall, alright? And that the distance from me to it is also 5 feet. So that means, right, that the A side of this triangle that I have formed is now 5 feet. And the B side is also 5 feet, the height of the light pole. Now, hypotenuse is about 7.1. Trigonometry. I want to thank all y'all for watching my video, and I appreciate you paying full attention, and I hope you learned a little something about circles, ellipses, parabolas, and hyperboles. But if there's one thing you take away from this, it's that you should always pay attention in Major Anderson's class, because you never know what you're gonna learn. And son, if you don't pay attention, it'll get you at the end of the quarter. Well, time for me to go. Hope y'all have a nice evening.